evaluate the limit as x approaches 0 of 1 plus x to the power of 1 over x from the left and from the right, round to the nearest 10,000th. So here we're going to evaluate this limit numerically by creating a table, actually two tables. One table that will represent us approaching the limit from the left, and the other table representing the limit as we're approaching it from the right. So we're going to approach it from the left. So we're going to create a table of values. We have our x here, and then the function is 1 plus x to the power of 1 over x. And we're also going to approach it from the right. And again, we have our x, and we have our function. So we're going to choose, as we're approaching from the left, we're going to choose values for x that are just a little bit smaller than 0, right? We're going to be approaching 0 from the left, from the negative side. So we can start here, for example, by choosing negative 0.1. If you evaluate that, you're going to get 2 point, and they want to nearest 10,000th. So that's going to be 4 decimals. So 2.8680. Then we're going to pick another value for x that is a little bit closer to 0, to the limit. So it's going to be, for example, negative 0.01, which gives us 2.7320. Let's try one more value, even closer to the limit 0, negative 0.001, which is going to give us 2.7196. And so we can continue getting closer and closer to 0 until we end up at 0. And if we plug in 0 here, well, we can't actually evaluate it because we're dividing by 0 in the rational exponent. So we can't actually evaluate it. But if we take a look at our approximations here, we can see that it appears to be approaching 2.72 if we round it to 2 decimal places. Let's do the same thing from the right. So this time we're going to pick a value of x that's a little bit larger than 0. So we can pick 0.1, which is going to give us 2.5937. 0.01. Now we get a little bit closer to 0. 2.7048 and 0.001, which gives us 2.7169. And if we now continue here to 0, again, we cannot actually evaluate this because we would be dividing by 0 in the exponent. Our prediction here, looking at the pattern to 2 decimal places, would be that we are ending up at 2.72 as x approaches 0. So the key here is that we're approaching the same value from both sides. Okay, we're approaching 0 from the left and from the right. So we can now conclude that the limit as x goes to 0 of 1 plus x to the power of 1 over x is approximately 2.72.